everyone, welcome to LeetCode number 206, Reverse Linked List. This is the iterative solution. Feel free to pause and read through the problem statement and get a hang of the problem before we start by walking through the examples. So let's get started by going through the examples that we've been given. So example 1 here has a linked list of 5 nodes, 1, 2, 3, 4, and 5. And what we want to do is we literally just want to reverse the linked list, or we want to get the arrows pointing in the opposite direction. So the final linked list is going to look something like this, where we see that the arrows have changed direction. And the same thing is happening in example 2, except we have 2 nodes. We have 1, 2, and what's happening is the arrows are, again, just changing direction. The examples actually have the numbers going backwards from left to right, but here it's the exact same thing. We can also think of it as just flipping the arrows just to make the problem a little bit easier. So now let's go through the intuition with this linked list with 4 nodes. So one thing we also want to consider is that it is unidirectional, so it is a singly linked list, and the problem statement says that we've been given a head of a singly linked list, so this is the value that we've been given, and we can also see that we've been given a next node. So we know where this node, number 2, is also located because of this arrow that goes between them, this arrow over here. So we know that we'll have to utilize these variables in some kind of way. What we also want to pay attention to is this final node over here, node 4, is pointing to something called a null pointer. So we know that after we flip this linked list and it looks something like this, we know that number 1 will now have to point to the null pointer. So we will have to introduce some kind of a null pointer in some way. So we're going to name that pointer previous, and we are going to set that equal to null. Next thing we'll have to do is we'll have to get this arrow over here to point to null pointer. But if we do that, we're breaking the link between this. So in order to keep the second half of the linked list into consideration, we will have to name the second half and the first node of that second half, and let's name it after. So the only way we'll be able to name this is before we set this arrow equal to null. All right, so let's walk through this example with 4 nodes. We have our previous, which is the null pointer, and we have our head, which is pointing to the beginning of our linked list. For the sake of simplicity, I'm just going to rename this head to cur, and just to make it a little bit more simpler for explaining. So what we want to do is first we want to check, is cur equal to null pointer? If cur is equal to null pointer, that means we are at the end of our linked list. So there's no more nodes that need reversing. So that's when we know that we need to stop. So then what we want to do is we want to set a node called after to the node after current. Again, this is because when the linked list breaks in 2, we want to know where the second half of our linked list is. Then what we want to do is we want to set current next, which is going to be whatever is pointing to the next node, to point to the previous node. So then after we do that, we can move all of our labels over by 1. So then we're going to move our previous to current. We're going to move our current to after. Before we move our after to the next node, we again want to check if current is equal to a null pointer. Because if we don't check that and we move our after to an after of a null pointer, that's just going to break our code. So then we're going to check, is current equal to null? It is not equal to null because it is pointing to the node 2. Then we are going to move our after pointer over by 1 again. And then we're going to repeat the same thing over again. We're going to set current next pointer equal to the previous pointer. We're going to move our previous pointer to the current pointer to the after pointer. Again, we're going to check, is current equal to null? It is not equal to null. So then we are going to move our after pointer over here, sets current next to previous pointer, and then once again, set previous to current to after. So now when we're at this point, we have to be a little bit careful because although current is not equal to a null pointer, whatever comes after our current pointer is equal to a null pointer. So whatever comes after is pointing to null. So we're going to use our same kind of intuition. We're going to set after equal to current next, which is null. Then we are going to move current next to equal previous. Again, we're going to set previous is next to cur. We're going to set cur's next to after. Now we check, is current equal to null? Yes, it is. So what we want to do is we want to return the head of our new linked list. So as we can see, it is perfectly reversed, and we're going to return previous. All right, so let's go ahead and let's code the solution out. So first, we're going to start with the scenario where we don't have any head pointer. So if we don't have a head pointer, then we just want to return null pointer. Then what we want to do is we want to set the two list nodes that we had previously talked about in our intuition, and these two nodes are going to be what determines the first half of the linked list. So we're going to set list node cur equal to head. This is just for simplicity's sakes because moving the head might be a little bit confusing. And then we're going to set a list node previous equal to null pointer, because remember that first node that we have before we reverse the linked list is going to have to point to null pointer. Then we're going to create our while loop. So as you remember, when we were going through our intuition, our while loop condition is while current is not equal to null pointer, we are going to continue to reverse that linked list. So then we're going to create a list node after equal to current next, because then we're going to make sure that after is actually being pointed to something, even though it's a null pointer. Then current's next, this is where the actual flipping happens, is equal to previous. So now we're making sure that that next pointer is going to point to what was before it. Then we're going to want to move our pointers. Remember, the order for this is very important as we want to start to shift those pointers over by 1. So previous is going to equal to current. Current is then going to equal to after. When we finally get to the point where current is equal to null pointer, remember how the previous pointer is now pointing to the new head. So we want to return previous. Let's go ahead and let's submit this code and see what happens. So as we can see over here, it's accepted and the runtime is working perfectly. Now let's go through the time and the space complexity for this problem. So let's go over the time complexity first. So we can look straight at our while loop over here, which determines that the switches that are going to be made is going to go for the entire linked list, which has n nodes. Therefore, our time complexity is going to be O of n because it is going to be completely dependent on how many nodes are in that linked list. We're going to then look at the space complexity, and the space complexity here is going to be determined by the nodes that I create. So I'm creating a current node, I'm creating a previous node, and I'm creating an after node. So here, these nodes are always going to be constant. Therefore, it's going to be constant space, which is O of 1. So that's all for today's video. Thank you everyone for watching, and I will see you in the next video.